As I already told you, we're going to focus where the angle is, so I'm going to give you the angle. Okay? So this is it. So this is the angle that I have to work with. Okay? And I have a side of 20. I have a side of 9. What do I need to do with this angle?
We need to find the hypotenuse.
We need to find the hypotenuse. Let's say that this is my hypotenuse. What direction does it have? I'm going to call this hypotenuse, I'm going to call it A. Okay? I'm going to call this hypotenuse A, and that is going to be my vector. From this hypotenuse, what is my horizontal component?
20.
Okay, my horizontal component, I'm going to call it AX, because X represents horizontal, and is equal to 20. Very good. What is my vertical component?
9.
9. Very good. Now, to find A, what equation I have to use? The one of A squared or the one of C squared?
The one of C equal A to a second power plus 2B to a second power.
Exactly. C squared equals to A squared plus B squared. And to isolate C, I just need to apply the square root of the formula. Okay? So, basically, whenever we need to find the hypotenuse, this is the formula that we need to use. The one of C. Remember this. C is the hypotenuse. So my hypotenuse in this exercise is going to be the square root of A squared, that is 20 squared. It could be 9, okay? It doesn't really matter. 20 squared plus 9 squared. My hypotenuse then is equal to the square root of 20 squared plus 9 squared, the square root of 481. And how much is this? $21.93. Okay, the hypotenuse. Remember that we already called this hypotenuse with the letter A, okay? So, in our formula, in our triangle, we're just going to write the definition of the hypotenuse. We're going to say that this side is 21.93. And then we analyze if it makes sense, okay? Is the hypotenuse the largest side?
Yes.
Yes. We don't know if it's right, but at least it makes sense, okay? Okay. Now, this is the angle that I have. And I want that you guys help me to see what is my opposite side to my angle and what is my adjacent side to the angle? Remember that opposite means in front, okay?
The opposite is the one of 20 and the adjacent is the one of 9.
Okay, that is correct. Opposite is the one of 20 because that is the one that is in front. And the one of 9, the side of 9, is the one that is the side that is touching the angle. Okay? This side right here is touching the angle. Okay? So that's why we say that this side is the adjacent side, because it is in touch with the angle. And the one of the that is opposite is in front of the angle. So I have my angle here, and the side that is in front is this one. And that side measures 20. Now, one more thing to analyze. What is the direction of the hypotenuse? Where is the hypotenuse going? Is it going to the right or to the left?
Left and up.
Right or left?
Left.
Okay, left. It is correct. It is moving to the left. If it's moving to the left, is it going to be positive for x or negative for x?
Negative.
Now, let's analyze if it's going up or down.
Up.
It's going up, okay? Because it is going up, is it going to be positive or negative for y?
Positive.
Positive. So with this, we are able to write with these guys we are able to write the signs, because in vectors we need to write the signs. So in x we said it's negative, okay, because it's going to the left. So this value here actually is negative 20. Why? Because it's going to the left. In y it says it's going up, so that means that it's a positive. So in y we have negative 20 because, sorry, in x we have negative 20 because it goes to the left, so it's negative. In y we have positive 9 because it's going upward. This kind of analysis is the analysis that we need to be doing whenever we see a vector. Some other times I'm gonna give you just the hypotenuse, and you will have to find the components. But let's try with another example of this. I want that you guys in this moment ask me if you have a question, or if you want me to repeat an explanation of a part of this procedure. Okay, there are no questions, so I continue with the topic. Let's analyze this other triangle. Okay. From this triangle, what is the missing side? Is that a leg or is that a hypotenuse?
Hypotenuse.
Okay, so here in this exercise, the missing side is the hypotenuse. Okay? So, because we need to find the hypotenuse, we need to solve for C. Okay? We need to solve for C. That means that in the first place, we're going to apply the formula to find hypotenuse. That is C equals to square root of a squared plus b squared. Okay? This is the main equation. This is what we know as the Pythagorean theorem. Okay? This is the main equation. Now, what do we need to do? We need to replace by the given. So the hypotenuse is equal to the square root of a squared. Which one do you want me to call a? 8 or 12? Doesn't really matter, I told you.
The 8 will be 8.
Okay, a is 8 and b is 12. Okay, so let's work like that. 8 squared plus 12 squared. The hypotenuse then is equal to the square root of, and we're going to add these two numbers in the calculator, sorry. So it's going to be 8 squared plus 12 squared. How much is that? How much is 8 squared plus 12 squared?
208.
208. Okay? And then the square root of 208 gives you how much?
14.42.
14.42. Okay? So, we now know the hypotenuse is not unknown anymore. It is 14.42. Sorry, 42. Okay? 14.42. That's the first thing that we do with a right triangle. Now, imagine that I say that this is the hypotenuse okay? And it has this direction. This vector is called C, okay? That's the name of the hypotenuse. That's a name, okay? You can name the hypotenuse whatever you want it, okay? You want to call it house. It doesn't really matter. But what it really matters is that you know how to identify what is the vertical component and what is the horizontal component. So which one is going to be Cx and which one is going to be Cy? Cx is the horizontal and y is going to be the vertical. So what is my horizontal component of this triangle?
12.
12. What is my vertical component in this triangle?
8.
8. Okay, now we analyze. Where is the hypotenuse going?
Left and down.
Okay, C is going to the left, okay, you have to see the direction of the arrow, okay? Where is the arrow pointing? It's pointing to the left, but also it's pointing downward, okay? So C is going left and down. If it's going to the left, remember, in a Cartesian plane or in a number line, okay, left is going to be negative and right is going to be positive, okay? So because it's going left, and x is going to be negative. So my horizontal component Cx is going to be negative. And I put a negative sign over there just to indicate the direction of this component. Also C is going down. Remember, in the number line, upward is considered to be a positive direction, while downward is considered to be a negative direction. This is for y, okay? This hypotenuse is going left, but also is coming down. Because it's coming down, the symbol for y is going to be negative. So my vertical component 8 is not 8 anymore. It's going to be negative 8 because it is going downward. So those are the two components of my hypotenuse. Now, let's analyze one more thing. Let's say that this is the angle. Okay? That is the angle that I give you. Sorry. That is the angle that I give you. Now we need to identify what side is opposite to the angle and what side is adjacent to the angle. Remember that opposite means, what does opposite mean? Does it mean in front or does it mean that it's touching the angle?
In front.
Opposite means in front. So what side is in front of my angle?
The one of 8.
So I have my angle here, and the side that is in front of this angle is the one of 8. So my opposite side is going to be 8. The adjacent side means that it's in touch with the angle. And the side that is touching the angle, the leg that is not the hypotenuse, okay? Because the hypotenuse, you know already that is going to be touching the angle. So the other side that is not the hypotenuse is going to be the adjacent side. Because this adjacent side is touching the angle in this part, okay? So we say that this is the adjacent side to the angle. Now, this is not the real topic, guys. This is only for you to adapt what is horizontal, what is vertical, if it's left is negative, if it's right is positive, up is positive, down is negative. This is only adaptation. These are not the exercises yet. I just want that you guys know what to do in the case that you need to find the hypotenuse. What do? You apply the Pythagorean theorem. That you guys know how to identify horizontal and vertical. That you guys know the direction of the hypotenuse, and that you guys know how to identify the signs of the hypotenuse. Okay? Well, the components that are making up the hypotenuse. Remember, in a Cartesian plane, this is what you have in a Cartesian plane. Okay? Basically, this is what you have in a Cartesian plane. In y is positive whenever you go upward. And in x is positive whenever you go to the right. I told you that from the first day of classes, basically. I remember I said that in the first or second virtual class. I gave you a Cartesian plane. Remember, up is positive, right is positive, down is negative, left is negative. Okay, keep this in mind. With this, you tell the directions of the components, vertical and horizontal components. And then from the angle, because we care about that position of the angle, we're going to analyze if a leg is in front or opposite to the angle, or if a leg is in touch or adjacent to the angle. So yes, we care a lot about the position of the angle. Now from this, we're going to learn the basic trigonometric functions that are used in trigonometry. They are called SOHCAHTOA. And it's called like that because in that way you memorize it faster. SOHCAHTOA. S stands for sine, O stands for opposite, and H stands for hypotenuse. K. C stands for the trigonometric function called cosine. A is for adjacent, and H is hypotenuse. TOA. T is for the trigonometric function tangent, O is for opposite, and A is for adjacent. If you know what S, C, T, A, and O means, you know the trigonometric functions. Okay? So remember this. SOHCAHTOA. Sine is equal to opposite divided by hypotenuse. So cosine is adjacent divided by hypotenuse, and TOA, that is tangent, equals to opposite over adjacent. So if you take a look to the right triangle that is here in the example, what is the hypotenuse? 8, 15, or 17?
17.
17, okay? So for that angle, what side is opposite? Remember, this is the angle, okay? I'm giving you the angle. What side is opposite to the angle? 8 or 15?
8.
8. What side then is adjacent to the angle? Or
15.
touch? Okay, 15. The one that is touching the angle is 15. So knowing this, knowing which one is hypotenuse, opposite, and adjacent, you can easily find those trigonometric functions. For example, sine of the angle is opposite, which is 8, over hypotenuse, that is 17. If you divide these two numbers, it's going to give you a decimal number. And that is the sine of this angle from here. You don't know the angle, but you know the trigonometric function related to that angle by just knowing the size of the triangle. To find cosine, you apply the formula. Adjacent to the angle, that is 15, divided by the hypotenuse, that is 17. Tangent of the angle is opposite over adjacent, opposite or in front of the angle, that is 8, and adjacent, that is touching the angle, that is 15. 8 divided by 15. Remember, we care about the position of the angle. So these are the three basic trigonometric functions. Now, are we going to use them all in physics? No. In physics, we just use, well, we use that 3. Yeah, we use that 3. There are 3 more, basically. But in physics, we're going to be just using these 3. But it's simpler than this, okay? This is just the definition of the trigonometric function. And no, this one I will explain in class better, okay? So, what do you have to do? You have to write the rest of the presentation if you haven't. And we're going to practice with this example in the next class for you guys to see how we calculate an angle in a right triangle when we know the sides.